So on today's lesson, we're getting into lesson 10.2. Now, yesterday when we talked about area, we looked at this chart real quick, and we dealt with these two particular areas, finding the area of a parallelogram. Parallelograms, once again, are opposite sides that are parallel. Can be a rectangle, can be a square, can be a rhombus where it's tilted, as long as the opposite sides are parallel. And then we use the formula base times height. Today's we're getting into this section where we talk about areas of triangles. And in areas of triangles, our formula still looks very similar because it's base times height, but then we're going to divide it by 2. And when we get into this, we'll figure out why that works every single time. So when I look at what it's asking me to do, it goes back to 10.1's idea of knowing what a rectangle is or a parallelogram. It says on the grid, draw a rectangle with a base of 6 units and a height of 5 units. So we can once again have base and height. We can have length and width, but most often we're going to see base and height throughout our book. And on the ISTEP test, you never know which one they're going to use. As long as we remember that base and length means the same thing, and width and height mean the same thing, you're going to be set and be fine doing these. So when it gives me my measurements then, I go ahead and I draw my rectangle, and it shows me that I have 6 because it told me a base of 6, and then a height of 5 because it told me I had a height of 5. And then when we look at what the area of that is, once again we use the base times height. Remember that we have to have a particular thing to know where the base and the height is. That's our right triangle, or that's our right angle. So our base is 6, and when I look at that right angle, I know that that other part that's touching it is going to be my height. So my height is 5. Multiply those together, 6 times 5 does give me 30. And once again, anytime I have area of anything, once again, area of anything, doesn't matter what shape I'm finding, I'm going to have square units. When I look at what this is asking me to do, then it says to cut out the rectangle, to trace it on a piece of paper and draw a diagonal line segment from one corner to another. And all a diagonal means is it's going to connect non-adjacent vertices of a polygon. Now that's 3 big words that we really haven't talked much about this year. Polygons is any straight-sided shape. Okay, so it could have 3, 4, 5, 6, 7, 8, 9, 10. We're going to talk about many of those. We're going to talk about triangles. We're going to talk about quadrilaterals, pentagons, hexagons, octagons, decagons. It doesn't matter how many sides it has, as long as all the sides are straight and then it's a closed-in shape. We basically deal with rectangles and triangles, but we will look at the others as well as we go throughout the geometry part of 6th grade. Non-adjacent means opposite. Why can't they just use the word opposite? I don't know. It is easier, but adjacent is the mathematical term for opposite corners. So when I'm looking at non-adjacent vertices, I have 3 different things when it comes to my geometry, when it comes to straight-sided shapes. I have vertices, which is a point. I have edges, which is a straight line. And then I have faces. If this was especially a 3-dimensional shape, then the flat part is the face. And we'll get into all of those when we get into the surface area, which will be not too long from now. Once I draw my diagonal line, then it says I'm going to cut it in half and look at what I have. So if I cut that in half, and I know that I have 2 congruent or equal triangles to one another, then what is my area going to be? Well, if it was a rectangle, it was 6 times 5, which is 30. Half of that then I do what? Divide by 2, right? So if I need just the area of the triangle, I know I'm going to have to divide by 2. That's why when we talk about the area of right triangles, I know it's base times height, always then divided by 2. When I take my base times height that I first started out with, my 6 times 5 is 30, and then I divide by 2, then I get 15. So if this was restated at the very beginning, well, what is the area of the right triangle? Then I would know it would be 15 square units. So then, when it says to draw some conclusions, this is where we think about and then write out an explanation to explain this information. How is it different? Well, how is what different? Well, how is finding the area of a rectangle like, but also different from a right triangle? So when I look at how they're like, finding the area of a rectangle and a triangle all start by multiplying base and height. So that's my first part of my answer. Finding the area of a rectangle and a triangle all start by multiplying the base and the height. Well, how are they different? Well, the triangles then have to be divided by 2, because a triangle is always going to be half of that parallelogram, quadrilateral, rectangle, square, depending on what shape you have. Well, number 2 just asked me then, okay, then if I know that information, what is the formula for finding the area of a right triangle? It is simply base times height divided by 2. And when we say divided by 2, it's always shown as a fraction because fractions are division. Well, if we stop and think a second, could I say that it's the same as 1/2 times base times height? Sure, it's still the same thing, but I find that this one is the easiest one to remember than trying to remember to multiply by 1/2. So look, we're going to go right into the practice problems. There's not a lot of explanation, so this is going to be a much shorter video than in 10.1. But I still want you to follow along. I still want you to practice these problems with me, and we're going to work through many of them instead of leaving several of them blank. It says to trace the parallelogram and cut it into 2 congruent triangles. Find the areas of the parallelograms of one triangle using square units. So I don't need you to trace it. I don't need you to copy it. We're just going to mathematically solve for what it's asking. Now, on this one, what is my height? I didn't have it, did I? So you're going to see that I extended this out, and I'd like to see you do the same thing in your book so that you know where the height is going to be. Now, you could have seen it. I could have drawn it in here also to where I made my right angle right there as long as it touched the top. But I was going to show you that where most of these are on the inside, this one I can also draw on the outside. The main idea is that I have to have a right angle so that I know what my height is. Without the right angle, I don't know what my height is. So once I look at my base, I can count 9 units. Does not matter that this is a half of a unit or this is a half of a unit, because I'm just counting how many complete boxes go across the bottom. And I'm just looking at those edges. And then when I look at my height, I have 4. So I know mathematically I have a base of 9, I have a height of 4. I'm going to take base times height, and then I'm going to divide by 2. So when I take 9 times 4, I get 36. And then divided by 2, 36 in my calculator, divided by 2 tells me that it is 18. And once again, my area label always has to be square. Now, if they give me the actual measurement, like below I have inches, feet, and yards, then I have to square that. Without it, then I know that it's units, and it's just squared units. So when I look at number 2, find the area of each of these triangles, and I'm always going to start where? I always start where the right angle is, and those are my 2 measurements that I use. My base is 10, my height is 8, so I multiply those together. 10 times 8 equals, I know it's 80, and then I have to divide by 2 because we're talking about the triangle. So 80 divided by 2 tells me that I have a measurement of 40. 40 what? 40 square inches. On number 3, I have my right angle, which is right there in the corner, and I know my measurements are 20 and 18. Now, I don't like the way this one is drawn, and the reason I don't like the way this one is drawn is because it gets a little confusing. It doesn't actually touch the top of the triangle. So I prefer to see that it's either drawn on the inside where it does touch the top, or on the outside where it touches the top corner. But it's not an inaccurate. I just don't prefer that way being shown. Either way, I still have the same height and I still have the same base. I still have a base of 18. I still have a height of 20. When I multiply those together, 18 times 20, I get 360. 360 then can't be my answer because that would be a parallelogram, right? So I have to divide by 2 because it is a triangle. So when I write all that down in my book, and then I hit divided by 2 in my calculator, I know that my answer is going to be 180. 180 what? 180 square feet. Number 4 then, finding my right angle. I have the measurements of 4 and 11. So I take my base of 4 times my height of 11. 4 times 11 does give me 44. 44 then, because it's a triangle, divided by 2, is going to give me 22 square yards. Are we still good? If you need me to slow down, then just pause the video and then restart it, and you'll be able to continue forward. So when I look at the next few, we're not going to do 8 because I don't need you to worry about describing it, but we are going to do these other 4. So when I start with 5, I know I want to start where my right triangle is every time. And where my right angle is, that gives me a base of 30 and a height of 33. When I have a base of 30 and a height of 33 and I multiply those together, that gives me 990. And when I have 990, that would be a parallelogram. So I have to find half of that because it's a triangle. Divided by 2 is going to give me a measurement of 495. 495 what? 495 square millimeters, because that's the label that they gave me. When I find my right angle for number 6, I know I have a base of 19 and I have a height of 20. I write those down. I show that I'm multiplying. I type it in, 19 times 20 equals, and I see that I get 380. When I take my 380, that would only be a parallelogram, so I have to divide it by 2. Once again, fraction bars are always telling us to divide. 380 divided by 2 gives me a measurement of 190. I plug it in, make sure my label's there, which they have given to me, so it would be 190 square inches. And then on number 7, once again, I start where my right angle is. My right angle tells me I have a base of 16, have a height of 12. Base times height divided by 2 tells me to multiply those two together for 192. Divided by 2 then, I know that I have a measurement of 96. 96 what? 96 square centimeters. So number 9, we're going to look at what it's talking about. If it helps you to draw a picture, please feel free to draw a picture. I'm not against you drawing pictures, as long as I can also see the math. There's a lot of times that I will draw pictures to help me figure out what it is that a story problem is asking me. This says a school flag is in the shape of a right triangle. The height of the flag is 36 inches, and the base is 3/4 of the height. What is the area of the flag? So now we have to remember what to do when it comes to fractions. When I have 3/4 of the height, I have the fraction of 3/4 of tells me to multiply, right? The height, and the height is 36. So that's where I have to start this math problem. I can't just jump into base times height divided by 2 because I have to figure out what that measurement is. So I have 36 of, and I have 3/4 of, once again, is the multiplication. I know I can't use 36 in a fraction in a multiplication problem, so I put my 36 over 1. I will always show you to cross reduce because, once again, as I have said on many of these videos, cross reducing makes my math so much easier, and I don't have to remember to reduce usually at the very end if I've cross reduced all that I can. 4 does go into 4 one time. 4 does go into 36 9 times. So I'm left with then a straightforward multiplication problem of multiplying across 9 times 3 is 27. 1 times 1 is 1, and I don't need a denominator of 1. So I know I have 27. But notice that's not the end of my problem. All I did there was I have found now the base of my flag. And so I'm going to use my information. I'm going to use the 36 they've given me, Now I'm going to multiply it by 27. 36 times 27 gives me 972. We're talking about inches once again. So then, once I've multiplied the base and the height that I found, I'm going to divide by 2 because it says that it is a right triangle. 972 divided by 2 tells me that I have 486 square inches for the area of my flag. Now when we look at this problem, it asks, well, which one is nonsense and which one makes sense? So when I look at this information, I know that Cindy and Tyson drew the models below. Each said that his or her drawing represents a triangle with an area of 600 square inches. Whose statement makes sense? Well, before we start doing that, let's ask the basic question that we started with in 10.1 and now in 10.2. What must I have in order to find the shape's area? Have to have a right triangle, right? So let's look at what they've given us. If I have a right angle, I said triangle, I apologize, a right angle, this is my right angle, this is my right angle, and then we said with 10.1 and 10.2, the two sides that make up the right angle are the measurements that I use. Did Tyson use those two measurements? Yeah, he did. He's good to go. How about Cindy? Cindy didn't. Cindy used this long line here. Now I'm going to go ahead and tell you, because it's something we'll get into, and that you might see on the I-step test. When I'm talking about a right triangle, this diagonal has a special name. This is called a hypotenuse. And you're going to see that I've used the word hypotenuse in my answer. And as you copy it down, I want you to use the word hypotenuse just so it's in your mind as to what a hypotenuse is. A hypotenuse is the long diagonal line of a right triangle. So when I give my answers, I'm going to say that, well, Tyson does indeed use it, and yet Cindy used a hypotenuse in only one side. So Tyson uses both sides of the right angle, so this makes sense. It answered the question, and it proved how I knew it answered the question. Tyson uses both sides of the right angle, so this makes sense. When I go to Cindy's explanation then, Cindy uses a right angle side and the hypotenuse. Once again, I'd like you to use that word. Hypotenuse, hypo, H-Y-P-O, 10, T-E-N, use, U-S-E, hypotenuse. So this is nonsense. So Cindy uses the right angle, one side, and then a hypotenuse, that long diagonal, which we don't use mathematically in this problem. So this is nonsense. So I answered both parts. On this one then, it says, a flag is separated into two different colors. Find the area of the white region. But I'm not given any measurements on the white region, and we haven't talked about how to find the space of a white region when it doesn't give me the measurements. So how are we going to do it? Well, what is the shape originally of the flag? It's a rectangle, right? And we said that it really doesn't matter what portion has measurements or not. If I divide it in half with that diagonal, that hypotenuse, then I know that this shape and this shape has to be the same. So the math looks exactly the same. I'm going to take my parallelogram of base times height for my rectangle. When I get that, I get 15, because 5 times 3 is 15. It's 15 square feet. However, since I'm trying to only find part of it, I'm finding the right triangle, the white space, or the blue, because it's still going to be the same. Then I have to multiply by 1/2 or divide by 2. I only need half of it. So 15 divided by 2 tells me that my area up here in this white space is 7.5 square feet. And maybe you're thinking, well, couldn't I put 7.5 square feet? Absolutely. You can use 7.5 or 7.5. They both have the same value. Now, we're going to do some extra math. And as I said in 10.1, going ahead in our book means that some of your I forget the word, but review questions on the back of your assignments are things that we haven't taught yet. So I'm going to make sure that I teach them to you or look at an example problem so you know how to set it up. So I'm going to look at this example problem. This is not in the book, but if we understand how this works, I'll be able to do what the book is asking me to do on my assignment. You want to know how many people can eat the rolls that you are making for your Thanksgiving dinner. You plan for each person to have 2. Well, how many can share the rolls that you prepared? So what I'm looking at is how I'm going to solve for that problem. When I first set it up then, I'm going to talk about 2 rolls per person. Okay? So if I know that each person can have 2, I'm going to have one person and they get 2 rolls. So I put 2p, which would be multiplying, so that I can find my p. I know I have 52 rolls. So what I'm looking for, if you recall from 10.1's video, we talked about doing the opposite function, the opposite side. And if I'm looking at what 2p is, I know that every person is going to be allowed to have 2 rolls, so it's multiplication. So if I'm taking multiplication 2 times the p, or 2 times the people, and I'm going to get 52 rolls, then my opposite function and opposite side tells me to divide by 2. If I divide by 2, I'm also going to do the opposite side, which tells me that I'm going to divide by 2. These, once again, cancel out, and I don't have to worry about them. 2 over 2 is 1. If this was 1000.56 over 1000.56, it would cancel out and still make 1. So what I'm doing over here is always going to cancel out and make 1, leaving me with that missing letter. I don't know what that letter is equal to. I have mathematics of 52 divided by 2 then. I know that if I divide 52 by 2, I'm going to get 26 people. So 26 people can participate in my Thanksgiving dinner and each have 2 different rolls. Another thing to recall that I introduced to you in 10.1 is inequalities. And once again, what I showed you in the last video, in inequalities, it just means what it sounds like, even though it's spelled weird. Inequality. And when we're talking about equality, we're talking about a number. And we have 4 different ways in which we can see that written. So my number that I'm looking for, and a lot of times it's going to be shown by a letter, and the 2 practice problems we're going to do today are shown by letters. So when I look at where my letter is or my missing number, I know that this is going to be equal to inequality that is less than whatever's over here. Because the arrow points to the smallest number, I know that whatever I'm looking for is going to be less than whatever's here. If the letter or missing number is here, and everything else is being pointed to, then I know this one has to be greater than. So it could be any number or inequality greater than what number is given to us. And then these were the ones that were a little different for us because they had weird lines under them. And I told you in 10.1 that the line underneath it just was half of an equal sign. So we know that it can be any number that is less than or equal to what is being shown. And if it's on this side, it's pointing away but it's underlined, it tells me that it can be any number greater than or equal to the number that's over here. So on your practice problem sheet, I have this information for you. Please follow along when I graph these 2 inequalities. This is another new thing for you. But these, I promise, I can't guarantee they're on the I-STEP test. That's why I've been assigning these to your Moby Max so you can learn what inequalities are. So starting when we got back from Thanksgiving break and you're doing your Moby Max, you should be practicing these. These will help you be successful Moby Max practices on the I-STEP test, but also on the NWA when we get to that here shortly. So when I'm looking at this, it says to sketch the graph of y is arrows not pointing to it. So what's that mean? But y has to be greater, right? Greater than 6 on a number line. So when I look at what it's saying, y is inequality, any number that can be used that is going to be greater than 6. Now when I graph them, there are two different things I'm going to use. I'm going to use circles and I'm going to use arrows. The circle will either be open or it will be closed. And all that means is it's going to be a circle or it's going to be a solid circle and filled in if it's closed. And we'll look at what that means for us here. If I'm talking about it's any number or any quality that is greater than 6, but notice that it's just greater than. It's not going to be equal to 6. So I'm going to go to that number that is shown and I'm only going to circle it. It's going to be left open. When I circle it, I know that I'm going to start there. But if it's not filled in, it cannot be equal to 6. It doesn't have that line underneath it. And then once I circle it, I know I'm starting at 6. I'm going to look at what else is said. It says it's anything that's greater than, because y is over here. And greater than, when I do positive numbers, is over to the right. So that's where my arrow comes into play. From the circle, I'm then going to draw an arrow. So if I look at this and I went in reverse, I would be able to write my inequality. I could know that I'm looking for a number. I could use X, Y, T, Z. I don't care what letter you would use, but I would use a letter and it would be not equal to 6. So I knew I wouldn't have an underline on it, but I know it would be anything greater than 6. So I could read it and write an inequality, but I can also take my inequality and I can graph it. When I look at this one, I see that my y is being pointed to, and the less than sign is underlined, and we know that it's -3. So the information that I can gather from that is y is inequality, or any number that is less than 3, because once again, it's being pointed to. Arrow always points to the smallest number. But I also know that it means that it can be equal to 3. So remember what I said about the two circles. I can have a circle that is not filled in, or I could have a circle that is closed. In this case, when it says that it can be equal to, I go to what it says it can be equal to. It can be equal to -3. I circle it, and then I fill it in. That's where my solid circle comes into play. And then my arrow, once again, tells me all the rest of the information. I start at -3. It can be equal to -3 because it's underlined. And then I know that it can be anything that is less than -3. And we always go to the left of a negative number to indicate less than. And once again, my arrow shows me all the other things that it can be. So then I draw an arrow and I just make it thicker. If you're lying, I can't tell that you've drawn the line over the arrow that I've given you, then you can't get credit for drawing the line. So you have to draw the line. Now I know that these can be confusing because it's new. That's why I would really make a strong suggestion to you, just like I did on 10.1. On these new things that I'm introducing, because it's part of your homework, go back that last 5 minutes and re-watch it so that you get what I'm saying, not just writing down what I'm doing. I need you to understand what I'm saying. Okay? So take that time, go back and review. The lesson, once again, is focusing in on the big chart that we said we're going to get to, but we're really looking at just the right triangles today in 10.2. Excuse me. My formula to find the area of a triangle, I go to where the right triangle is, that perpendicular height, and then I find the base and the height. I multiply those together, but then, because it's a triangle, I divide by 2. Rewatch this video anytime you need to. Use it at home. Go back and rewind just to a few sections in case you fell behind, didn't get it written down, or you just didn't quite understand. Then look at the board for your homework assignment. If you have questions while you're working on it, come back and ask.